In this video, we will continue to practice solving systems of equations by graphing. First, let's review the steps to solving a system by graphing. First, you need to solve each equation for y so that each equation is in y equals mx plus b form. Then, graph the first line by plotting the b value on the y-axis, and then use the slope, rise over run, to plot several more points, making sure that you extend the line in both directions. Then, graph the second line the same way, and finally, find the intersection point. This is the solution to the system, and make sure to write your answer as an ordered pair, x, y. In the first example, we're going to solve the system by graphing. So our first equation is x plus y equals 1. In order to graph this line, we have to solve to get y by itself. So if I rewrite my equation, so x plus y equals 1, if I want to get y by itself, I have to move the x. So I would subtract x from both sides to get y equals negative x plus 1. And that means that the slope is negative 1 over 1, and the y-intercept is 1. So I can graph my y-intercept at 1, an additional point going down 1 and over 1, and then draw on the line. Then we're going to do the same thing for the other equation. So our other equation is 2x plus y equals 4. If I want to solve to get y by itself, I have to move the x. So I would subtract 2x from both sides to get y equals negative 2x plus 4. So the slope is negative 2 over 1, and the y-intercept is 4. So I can plot my point at 4 on the y-intercept and graph another point using the slope. And then finally draw on the line. Now the intersection is the solution. So in this case, the solution is 2 comma negative 1. In our next example, the first equation is x plus 2y equals negative 2. If I want to solve to get y by itself, I first have to move the x by subtracting x from both sides. So I'm left with 2y equals negative x minus 2. Then, to finish getting y by itself, I divide everything on both sides by 2. So I'll have y equals negative 1/2 x minus 1. So your slope is negative 1 over 2, and your y-intercept is negative 1. So I can plot my point at negative 1 on the y-axis, go down 1 over 2, and draw in the line. Now the other equation is 3x minus 4y equals negative 16. If we want to solve to get y by itself, I first have to move the 3x over by subtracting 3x from both sides. So I'll have negative 4y equals negative 3x minus 16. Then I would divide both sides by negative 4. So I'll have y equals negative 3 divided by negative 4 becomes positive 3 over 4 x, and negative 16 divided by negative 4 becomes plus 4. So I can graph my line by plotting my y-intercept, using the slope to graph another point, and then drawing in the line. Now the solution of the system is the intersection of the two lines. So the solution is negative 4 comma 1. Now we're going to review special cases. The first type of special case we have is called infinitely many solutions. And what this entails is that the two separate equations end up resulting in one line. So for example, here is an example of infinitely many solutions because there's only one line, so they intersect in an infinite number of places, so every possible number would be a solution. The second type of special case we have is called no solution. And this is something like we see in this graph, where we have two lines that continue forever and ever, and are never going to cross, and these lines are called parallel lines. Now because parallel lines never intersect, they don't ever have a possible location we can say is the solution, so this is why we call it no solution. In our first example, we're first going to graph the equation x plus y equals 4. So if we solve to get y by itself, we would have to subtract x from both sides. So if y equals negative x plus 4. So the slope is negative 1 over 1, and the y-intercept is 4. So I can graph my y-intercept, plot another point, and then draw on the line. Then for the other equation, we're going to solve to get y by itself again. So in order to do so, I would subtract x from both sides. So if y equals negative x minus 3. So the slope is negative 1 over 1. The y-intercept is negative 3. So I can plot my y-intercept, use the slope to graph another point, and then draw in the line. Now, since the two lines are parallel and never intersect, this is what we would call no solution. Now for the next example, we're first going to solve for y in the first equation. So we have negative 6y equals 9x plus 18. If we want to solve to get y by itself, we would have to divide everything on both sides of the equation by negative 6. So we'd have y equals negative 9 over 6x, and 18 divided by negative 6 is negative 3. Now that 9 over 6 can simplify to negative 3 halves x minus 3. So I know that my slope is negative 3 over 2. The y-intercept is negative 3. So I can plot my y-intercept, graph another point on the line, and then draw in the line. Now the other equation is 2y equals negative 3x minus 6. If we want to solve to get y by itself, I have to divide everything on both sides. So I'll have y equals negative 3 halves x minus 3. So the slope is negative 3 over 2, and the y-intercept is negative 3. Now notice that the two equations that I have are the exact same. So if I were to graph my second equation, I can plot my point at negative 3, plot my new point using the slope, and my equation will be lying directly on top of that line. Now this means that the lines are going to intersect all the time. So there's not just one solution or no solution. This time there's what we call infinitely many solutions.